Chapter 21, Section 4 deals with chemical reactions and the energy exchanges involved. An example, dynamic explosion is an example of a rapid chemical reaction. Most chemical reactions proceed more slowly, but all chemical reactions release or absorb energy. That means they give off energy or take energy in. Energy can take many forms, such as heat, light, sound, or electricity. Chemical bonds are the source of this energy. When most chemical reactions take place, some chemical bonds and reactants are broken, which requires energy. In order for products to be produced, new bonds must form. Bond formation releases energy. Chemical reactions that release energy are called exergonic reactions. In these reactions, less energy is required to break the original bonds than is released when new bonds form. As a result, some form of energy, such as light or heat, is given off by the reaction. Familiar glow from the reaction inside a glow stick is an example of an exergonic reaction, which produces visible light. When the energy given off in a reaction is primarily in the form of heat, the reaction is called an exothermic reaction. And we'll take a look at an exothermic reaction on Monday when we build heat packs. The burning of wood and the explosion of dynamite are exothermic reactions because they give off heat. Sometimes a chemical reaction requires more energy to break bonds than is released when new ones are formed. These reactions are called endergonic reactions. That means the energy goes into the reaction. The energy absorbed can be in the form of light, heat, or electricity. When the heat needed is in the form of heat, when the energy needed is in the form of heat, the reaction is called endothermic reaction. Some reactions are so endothermic that they can cause water to freeze. One such endothermic reaction is that of barium hydroxide and ammonium chloride in water. Energy from the surrounding environment is absorbed, causing a cooling effect. Here the reaction absorbs so much heat that a drop of water freezes and the beaker holding the reaction sticks to the wood. Some reactions proceed too slowly to be useful. To speed them up, a catalyst can be added. A catalyst is a substance that speeds up a chemical reaction without being permanently changed itself. When you add a catalyst to a reaction, the mass of the product that is formed remains the same, but it will form more rapidly. At times it's worthwhile to prevent certain reactions from occurring. Substances called inhibitors are used to slow down a chemical reaction. One thing to remember when thinking about catalysts and inhibitors is that they do not change the amount of product produced. They only change the rate of production. This concludes the lecture for Chapter 4. Question number 1 asks, what is the difference between exergonic and exothermic? Exergonic, again, exergonic means that energy goes into the reaction. Exothermic means that energy comes out of the reaction. Exergonic reaction, chemical reaction that releases energy. Exothermic reaction is an exergonic reaction that releases heat. Oh, I'm sorry. Excuse me one more time with my explanation. Exergonic and exothermic. Exergonic means that it releases energy, and exothermic means that it releases heat. Heat comes out. Question 2. When heat is needed for a chemical reaction, it is called what? When heat is needed for a chemical reaction, it is called a endothermic reaction. Energy is needed in the form of heat. What is a substance that speeds up a chemical reaction without being permanently changed? That is a catalyst. Substance that speeds up a chemical reaction without being permanently changed is called a catalyst. And this concludes the lecture notes for Chapter 21.